what can happen is, for example, if this structure, for some reason, it's not able to take the vertical load. So then how, okay, so first of all, how many unknowns are there? 6. And the available equations are 3. So 6 minus 3 is equal to, it's indeterminate by 3 degrees. So there are 3 available redundant actions. Okay, and by that we mean that if for some reason this thing, the vertical reaction, is not being able to transfer, will this structure collapse? No. No. Why? Because you still have 5. You have a 2 degree indeterminacy. If, for example, it's not able to transfer the moment, or in other words, it becomes pinned by accident, still you have 1 degree indeterminacy. So you still have a stable structure. What will happen if this thing, if you are not able to transfer anything like that? Still it will work for you. Why? Because you have got 0 degree indeterminacy. But the moment anything happened with this one, okay, so your structure will become unstable and it will collapse. So that means to say that if your unknown reactions are less than the available equations, then your structure is unstable. Can you say that? Like, for example, I told you that you have, for example, if this gets failed, this gets failed, still it's 0 degree, it's a determinate structure. It becomes a determinate structure. But what will happen if, for example, this thing, it's not able to transfer this flow? What will happen? So you have 2 unknowns and you have 3 available equations. Okay, and so what has happened? So this has become unstable. So whenever your unknown reactions, and you can see, if it's not able to take this vertical load, it will keep on coming down. There is nothing to stop it, isn't it? So, but mathematically, this thing, what has happened? You have the unknown reactions which are less than the available equation. So that is something. So that is the condition for your stability. For stability, it is important that your unknown reactions, they are never less than the available equation. They have to be greater than available equation. So whichever structure you are going to design, you must keep sure that the available equation is at least equal to the unknown reaction. Okay, so that's what we have in the case of stability and determinacy. Okay, so there is another equation which is normally used, and that is called R is equal to 3n. R is the unknown reaction. 3 times n means n is the number of available members. Okay, and 3 times n. Okay, if this is satisfied, if R is equal to 3n, then you have a determinate structure. So let us test it on this one. So you have got unknown reactions. How many in this case? 3. R is equal to 3, and the number of members in this one is 1 member. Okay, so R is equal to 3 times 1 is equal to, so yeah, so you have got 3 is equal to 3, and this is a determinate structure. Okay, and in this case, what is your R? R is equal to 6. N is equal to 1. So R, so 6, but it's greater than 3 times 1. So 6 is greater than 3, which means to say that it is an indeterminate structure. If R is greater than N, okay, so this is a determinate structure and this one is indeterminate structure. Okay, and if R is less than 3n, then that is unstable structure. Okay?
So unstable and indeterminate are same?
Sorry?
Unstable and indeterminate structure are same?
No. Unstable means it's not a structure at all. I mean, you can't keep it stable. It's not in equilibrium. It's moving. So unstable, you have to ensure that the structure is stable. So you can't have unstable and determinate the same. In unstable case, your reaction is less than the available equations, which are 3 times n. Okay? In the case of determinate, it's equal to it. The unknown reactions are equal to 3 times n. So that's why I've written it in red. This is a danger area. Okay? You must ensure that this thing is not like you must ensure that the structure is stable, and this condition is never satisfied. Okay, so this is actually the violation of stability. You understand my point? So this is your determinate structure, indeterminate structure, and unstable. Now the question comes: what is n? The number of members. Should I wrap it off?
Yes, sir.
How many reactions this would have? 5 reactions. Okay, why is it 1 or why is it 2?
One, sir.
Okay, so in this case, you should remember one thing about n. N in this case is 1. And the reason is because this is one continuous structure which is going all the way. You might have hundreds of supports, but the structure is continuous. The moment a discontinuity comes, and what do I mean by discontinuity? Like, for example, you have an internal hinge Okay, you have a shear discontinuity, you have a movement, you allow movement like this, or you allow movement, axial movements like this. These ones are very rare, but internal shear hinge is very common. Okay, so if I put, so for example, let's do this one. Then I'll put an internal hinge and show you like how and changes. Okay, so this is one. It's an intact structure. It is one structure which is just placed on the support. Okay, so it's just one member. G.
सर अगर इस पे हम वो सुपरपोजिशन वाला जो आपने बताया था अगर वो अप्लाई करें तो दो हाफ में ब्रेक करेंगे फिर n को 0.5
No. Superposition is different thing. Okay, superposition is not. You can't have a superposition in case of indeterminacy. You can't have that. I've got one structure which is indeterminate and you that's different. Okay, superposition always comes when you know all the reactions and you are trying to find out the other unknown factors. Okay, other unknown parameters. So superposition you can't apply over here. It's not matter of superposition. You can't have that I've got this one separate and this one separate. I add the indeterminates. I find out my R and N's. Okay, and then add it up. No, it doesn't work like that. In indeterminacy, superposition doesn't work because these formulas are not derived using superposition. These formulas are derived based on something called graph theory. Okay, and that's a different. That's a mathematical way of working out the unknown factors. So, but you can't apply your superposition in case of statically determinacy or indeterminacy. Okay, so you have got n is equal to 1 and r is equal to 5, and so your r is greater than 3n and r is 5 is greater than 3 times 1, which is equal to 3. Okay, so it is indeterminate by 2 degree. Okay, so you r minus 3n is equal to 2 degree indeterminate. Okay, so this is indeterminate by 2 degree. Now, what happens if okay, so what will happen if I put a internal hinge over here? Your n will become 2.
And it will become unstable.
But is it unstable?
Yes, if n becomes 2, then P2 is 6, it becomes unstable.
No, but how about your reactions?
Reactions would also increase.
Reactions would also increase because you will get one additional equation. Huh? Yeah. You have summation of n z is equal to 0, but you will have another equation which is summation of moment at this point must be equal to 0. One is for the whole structure. This one is for equilibrium, isn't it? So summation of fx is equal to 0 means that this sort of movement is not allowed. Okay? Summation of fy means that this sort of movement is not allowed. And summation of moment means that this sort of moment is not allowed. Okay? So any axial, any vertical or any rotation that has to be, that's not allowed. So internally the structure is stable. Why? Because all of these, everything is 0. So your desk which is over here, that desk is stable. It is in equilibrium. Why? Because all these equations are satisfied, isn't it? So, but in addition to that, you have another equation which is summation of moment at this point must be equal to 0. Isn't it? That's one additional equation. So with that, so what will be your R in this case? Let me write it in green. So for the second case, R is equal to 1, 2, 3, 4, 5 and 6. Your N 2 and 6 6, and so this has become
Sir,
G.
how has the reaction become 6?
How? We already have how many reactions? 1, 2, 3, 4, 5.
And we add 2.
Okay. So we have got 5 reactions and we have got one internal moment. So
Total 6.
but how has, so you have R is equal to 6. How has that internal moment contributed to your reactions?
Summation M at this point.
Huh?
Summation M at range is equals to 0.
No, but I mean like the unknown. We are talking about unknown.
The moment about one side of a hinge is also 0.
No, but we are talking about this one. Look, we said that reaction, how is reaction equal to 6 in this case? These are unknown moments. Yeah, this is correctly pointed out. How have we added the unknown moment, which is this one, into this one? The moment is 0, that's true, but these are unknown reactions. Moment 0 is additional equation. The moment, this one gives you an additional equation. So how will this become 0? How will this become 6?
There will be some additional reaction that makes the moment 0.
No. There is, because this can't be added to this one. That's what my point is. If you increase the number of moments, if you increase the number of available equations, that goes over there. That's what I was trying to tell you. Increasing moments goes there.
Goes to N.
Yeah, this is where this is telling you the number of equations.
Yes.
This one is telling you number of unknowns. So R will stay
5.
it will stay the same. It is 5. It can never.
Yes, sir.
R will stay the same. Do you understand my point?
Yes.
Look, there are two things. The reason I am demonstrating this to you is that you have got two sides. One is the unknown reaction, one is the available equations. You don't make this mistake of adding the equation, available equation, to your unknown reactions. Okay? Unknown reactions are unknown. The fact that you have provided internal range, that has contributed to the available equation, not to the unknown reaction. Yes.
सर ये तीन इक्वेशंस की वजह से 3 है ना अगर इक्वेशन बढ़ जाएगी 4 n हो जाना चाहिए
नहीं 4 and नहीं, you will have 4 equations. You will have 4 equations. So this thing must be equal to 4. This is 3n because you have got 3 times the number of member. Okay, but adding this has increased your overall reactions. Your overall available equation. So this must be okay. So this
Unstable.
no. This is stable. Look, the reason I am doing this for you is that in this, don't just close your eyes and just put values in this. What I was trying to tell you in the previous class, use your engineering judgment. Use your judgment whether it is unstable or not. Okay, look, you guys are just, I've given you one formula and you are just throwing numbers in it. And you are saying that whether it's stable, unstable. First thing which you should do is, you think about it whether it's really becoming stable or unstable. Without anyone giving you any formula. Just think over it whether it is stable or unstable. Look, the reason I did this thing for you is that if you close your eyes and just start putting values in it, you will get very nonsensical results. And for that, you must use your engineering judgment. Now you are saying that, okay, now we have got this structure and we have provided an internal hinge. Okay? This was 1, 2, 3, 4, 5. 5 reactions, yeah? How many unknowns? How many available equations initially? 3 equations. By introducing an internal hinge, we have now one additional equation, which is 4. So 6 minus 4, you must get 2 degrees. So this is stable. This is not unstable. And how can it be unstable? If you just provide one hinge over here, okay, this can always take load, because okay, if you stand over here, what will happen? You can always have this load being transferred to this point, isn't it? If anyone is standing over here, what can happen?
So what actually does this?
Initially, your structure is straight, okay, like this.